stupid. As I discovered yesterday, PowerPoint Mobile is a bit different. Anyway, why are we here? How many people are familiar with full-text searching and Lucene? Has anybody used Lucene? Has anybody used Elasticsearch? Has anybody used Hibernate? Has anybody used Google? Okay. So Lucene is, well, let's go into what it is, right? Intro to Lucene, 10 more questions, very short. So it's a full-text search engine, right? It's not, most people here who have done database stuff, you may have done some NoSQL stuff, which are property-based. Mostly everybody's done SQL-based, which is very rigid. Everything has to be fully schematized. It's wonderful if you're doing bank accounts, but like I said at the beginning of the talk, in operations and administration, everything you know is a little bit wrong because it's always behind the time, right? Oh, my machine's up. Well, no, it crashed while I was getting that message. So data is imprecise, and using a very precise store like SQL is constrictive. So full-text search engine, you can search it searches every word in the document you're indexing. It's an Apache project. It's used by pretty much everybody. We're going to look at the Lucene.NET variant because PowerShell and Java are two great tastes that don't taste great together. And the Lucene.NET it's also an Apache project. It's a peer project with the Java version. It tends to trail the Java version a little bit, but they're doing a really good job of keeping up with it. And the version I'll show you is really old, and it's still mind-blowing. What it is, so it's closer to JetBlue, or Jet Red, or Turquoise, or whatever it is this week. The little in-memory database that comes with Windows. And so it's an in-memory database, no server, no SQL, none of that stuff. It's very easy to use, as I will demonstrate. For high availability applications, that's where you get into things like Elasticsearch and the Apache Solr project. Solr is used by OMS Operations Insights, right? So they're using Lucene under the covers. Application Insights was using Elasticsearch, so they're using Lucene under the covers. Basically, everybody who's doing anything with full-text search is using Lucene in one form or another. You have the choice of building indexes in memory or on disk, and you'll see why that's less interesting than it might be. It also provides a very simple query language of its own. We'll take a look at that in a minute. So glossary, because it's different than a SQL database, things are a bit different. When you bring data into it, you're doing ingestion, as though you are hungry and you're eating data. So bringing it in, the index is the database of searchable entries. That it's not terribly unclear. Then there's the analyzer. The analyzer is the piece of code that takes the raw text and converts it into a form to be ingested. There's a default analyzer that just does full text. So you pass it a document, a file, whatever, and it will index every word. There's another variant that will make Jeffrey happy that does stemming and gets rid of all of the pluralizations and things like that. And those are stock, but you can write your own, right? So if you have a semi-structured piece of data, then you can write something that will ingest. So you can say, well, I want to search against specifically, this field or that field. But it's entirely up to you. Everything else is still fully indexed. Indexing is taking a piece of text and adding it to the index. And then querying is using the Lucene query language to retrieve results. Not a surprise. Here's the Lucene architecture. One of the things that it does is it stores the full text of the ingested database. So you don't have, here's my index file and here's everything else over here. Right, it does store the full text. The overhead, so doing the indexing gives you only a 20 to 30% increase in the size of the total data, which is amazing, right? It really doesn't bloat your data a whole lot. Incremental indexing is almost as fast as batch indexing, so you can index in real time. So search tools like Google or whatever, you can continually update the database and it doesn't slow things down. You don't have to lock the database for updates. You can ingest about 150 gigabytes per hour per instance. So it's fast. This is sort of the basic architecture. I talked about like the analyzer and the index and all that sort of stuff. I stole it from somebody, it looked cool. Who uses Lucene? Pretty much everybody. Apache Solr, which is used by everybody. Like Chef, for example, uses Apache Solr. Elasticsearch uses Lucene. Everybody uses Elasticsearch. Visual Studio, Team Foundation Server uses Elasticsearch to do a lot of the searching stuff. Basically, if people are doing full text search, they're using either Lucene or something built on Lucene. Apple uses it, the Sightseer technical paper reference thing uses it, Comcast uses it, Disney uses it, right? It's basically used by everybody. It's sort of the gold standard of full text searching. From Wikipedia, it's suitable for any application that requires full text search. It's used by internet search engines in a distributed way, or alternatively, it's done for a lot of single site searches. So if you want to do a quick search engine for a website, then you can do it with Lucene quite easily. And it's a little bit of the architecture. The core of Lucene's architecture is this idea of you have a document and the document has fields. The default indexer treats the entire content as a single field. And the API can, because you have these analyzers, you can feed it PDF files or Word or whatever. As long as the analyzer can extract text, then the document can be indexed. And images are explicitly not supported unless you turn them into text. So a little bit about the query language, get an idea of how simple it is. If I had a field named title, then I could say search for the word food in that field. If I want to have spaces in there, I put quotes around it. If I want to do logical and, I use a logical and. I can use parentheses to do order of operations, and then I can use negation. So you now are experts in the Lucene query language. It also allows you to use wildcards. You can't use wildcards at the beginning of words. You have to be at the end, or I guess in the middle. That's because of the way the stemming works, right? So it does the index on the beginning of the word. Probably uses a try. Demo. Okay. So how many people have tried to search? Ah, yes. Thank you. For heaven's sakes.
Escape.
There. Probably regret doing that. And so how many people have tried to do a search in help?
Okay.
Well, actually, that one worked surprisingly quickly. So it's still coming back fairly quickly. But a lot of time when you try and do a search on help, if it's not indexed, I think we've actually fixed it to make it faster. But it's tragically slow. And even so, can everybody read that? Is that big enough?
Yeah.
I can't read it, so I'll make it bigger. All right, so that took a second, 1.6 seconds, to do a relatively simple help query. So let's see what we can do with Lucene. We'll walk through the script a little bit. I'm using a million namespaces because Lucene has a lot of namespaces. I only need to load one DLL. That's the extent. There's a separate DLL that has other indexes. But the only thing I need to do Lucene work is a single DLL. Just put it in place and just load it. I wrote a module for it and promptly proceeded not to use it because it's so straightforward to use Lucene that you'll get a big advantage of wrapping it in a module. So I need an analyzer. Okay, I'll get the standard analyzer using the current standard analyzer. You have a choice. If I want to store the index in memory, so I want to do a full in-memory indexing for high speed, I can do that. But in this case, I'm going to create an index on disk. So again, very, very straightforward. I could wrap these in commandlet, but there would be a one-to-one correspondence. And then I'm going to load all of the help files, all of the text, the about files. And I'm also going to load, so what I've done is I pre-formatted all of the help files because actually generating all that format data takes forever. It's really, really slow. So I'm going to ingest the full text of all of the help files, and then I'll start querying against them. So we'll ingest all the text, and then we'll go into a loop allowing you to do queries. So let's run this little script. So I'm indexing the help files. I'm going to find that it's all being paged out, so it's going to be slow. Or it's hanging. Cool. Yeah, that's moved very well. Let's try that again without all the stuff paged out. So get a more realistic sense of the index. There. So I index the full text of every help file, every mammal file, and every about text file in 1.7 seconds. I now have a fully searchable index. And this is one of the reasons why the idea of having it in memory is not a big thing. That's writing the index to disk. If it's in memory, then it's way faster, right? The speed at which Lucene can index means that you can take bags of data and just index them, and it's not like waiting 20 hours for SQL to ingest everything. The indexer is really fast. So let's search for something. Pick a command line, any command line.
Get process.
Get process it is. And it took 96 hits because there are a lot of things that say also get processed. But look at how long that search took. 7 milliseconds to search all of the text of PowerShell's help. 7 milliseconds. That's faster than accessing a hash table in some cases. So it's really fast.
What would you get as a result?
Everything that had the word get process embedded into the, actually it's going to split it on the hyphen, so it's going to be anything that's get and process. Right, so we got a smaller number of hits because of that phrase. And yeah, so now it's getting things that don't say module. I get a smaller subset of the hits. Yes?
Does it work with regular expressions?
It doesn't use regular expressions, it's full text.
Okay.
You can do post-processing, so like there are roughly 2,500 entries in the text that I indexed, which is now being subsetted to 23, which you can apply regex against trivially. So you can do gross-grained filtering and then sub-filtering with regex or whatever you want.
Okay.
But it's really easy, you know, compared to 2,500 entries. In fact, wait. So this is the help file directory. This is where I put all the staged files, excluding the about text. And let's just do a grab. Don't ask me why we don't have a standard grep alias. I do. So it's pretty quick. But it took 800 milliseconds versus 7 milliseconds.
But I understand that output. I still didn't understand the output from the stuff you showed. Because it looked like we searched for stuff and then we got text, but none of the text we searched for.
Yeah. So what I'm doing, just because it finds a lot of hits, I'm truncating the text at 120 characters. So I'm not giving you the full page. It looks like crap. When I show the other example, it'll be a little more obvious. But yeah, I just didn't want to have, because some of the help file entries are really long and I scroll right off the screen and stuff. I could have processed it into just the help, like the synopsis line, for example. But just the fact that I can search this text so fast. This is fast enough that you can use it, where's David? This is UI fast, right? This is something you could use. You can do full text search in the context of a menu. It's that fast. You know, 1 second is way too slow. 7 milliseconds is perfect. So let's take another example that may be more germane to admins. Looking at event logs. We had a discussion this morning with happened. So what I've done to get ready for this is I grabbed 10,000 entries out of my event log and dump them onto disk. So they're in little text files. Once again, I'm going to ingest all of these things into my database and then do some queries against it. The code is almost identical. You could write a standard application that you pointed at a directory and then did queries against it. But again, writing individual commandlets against this stuff, I haven't figured out the right factoring to make it actually advantageous. So if anybody has ideas, that would be cool. So again, basically the same thing. We'll run the script. And again, it's paged out, so it'll take a while. And then I'll run it again and it'll be really fast.
Short question. If it's capable of searching nearly every file format, you shouldn't need to export your event logs first.
Well, the event logs, it needs to be text. So you could, so what you could do is, rather than exporting them to text files and indexing them, you could write an indexer that took each individual event log record and dumped it into the database. And that would be the right way to do it. But I was writing a piece of code this morning, so I didn't do that.
Okay. That's okay.
Where I try and demonstrate something that's incredibly fast and it turns out to be really slow.
Okay, those 10,000 entries, how much data is that in these?
I have no idea. I can find out. It'll take a while. Right. So it took 54 seconds to index 10,000 entries. Well, let's run it again when the disk is hot. It should take about 3 seconds. Yeah. So if the disk is hot.
It's 3.8.
Oh, well, I'm sorry. I owe you 0.8 seconds. Take it out of my pay. But, it's 10,000 entries indexed in 3 seconds. So again, just the incredible speed at which this can index large volumes of data is amazing. And now we can start looking for things like, right, so here I'm dumping the full event log with lots of space between it. Right, I got 247 hits. I searched 10,000 entries in 2.7 milliseconds. Full text. Right, not searching one field, not searching an index key, full text.
So is each record a file?
So yeah, so what I did is I dumped each, because I have a crappy piece of code here, what I did is I dumped each event log record out as an individual file. So I ran get event log format as a list, format list, and then dumped it into a file. And that makes it super easy. I could have just streamed that directly into the thing as well, besides writing it into the file. But reading the event log is slow. So, I mean, it took way longer to do the export from the event log than to do the ingestion. I should actually see how long it takes if I go directly into the database. But let's go more specific here. One record and 0.5 milliseconds. So, just stunningly fast. Let's look for error. Lots of things with error in them. Right, and so one of the things that, like I was saying earlier, that you would probably want to index on properties. So here, what I've taken, this is all considered to be one single field. But for example, you could have an analyzer that split the text into individual fields. It talks about domains here.
But could you do like instance ID star colon star 129?
Instant ID star, you can do some limited stuff, but let's see, star instant ID. In theory, this works, I think, but the way I've got things set up, it's not working right. Star 129. So according to the manual, this works, but it's not working, obviously.
What? Looks like it worked.
Oh, it did actually.
Yeah.
That's fine. Oh, you're better at this than I am. That's why he gets the big bucks. But for example, if you want to look at times, right? You know all the events that happened at 4/18/2016. So it gives me all of the events that occurred at that time. So you can do things like, you see an error, and because it goes down to seconds, you can say, give me everything that happened in that second around that event, or everything that happened in the 2 seconds around that event. So you can do these like really deep queries, all the really cool stuff that you can do with OMI. You can, or not OMI, operational insights, right? This is the root of what they do, but you can do it yourself with only a few lines of PowerShell code. So that's my demo. And then find my deck again.
That's not good.
Hello deck, where did you go? Hola, no está aquí.
Run into a problem.
It's installing in the background, I think.
Well, that thing's been installing for 2 days. So, yeah, several times, like whatever. So let me start my deck again. This is one of the things I was saying about the PowerPoint Mobile, is it just kind of goes away. And you'd think Shift F5 would work, but no, it doesn't. Oh, it did work this time. Oh no, it didn't. Haha! See, fooled you. It looked like it was going to work, and it failed. So we've done our demo. So my conclusions are, Lucene's awesome. And the possibilities, so I've only begun to sort of scratch what could be done with Lucene. If you have to deal with large volumes of data, like say Sapien might want to be, where's June? Sapien might want to be able to do log analysis as part of the tools, or we want like the output of script analyzer. You can do full text search against that output to find different types of problems. Just that ability to do that level of searching. One of the things that I did that I can't show you because it would involve showing you the source code was I indexed all of the PowerShell source code, which is large. And it was awesome. I could find every function very, very quickly. I could find any class faster than I can find it in oh God, way faster than I could find it in Visual Studio because of the sheer size of things. So just anything that you might need to index, source code, inventory lists, anything that you might want to correlate, you can ingest to, because it doesn't have to be a regular database. It's not like you have a single consistent schema, you just have lots of text, right? So you can index different types of data into the same database and then query against both. So the possibilities are just amazing. And I've got to figure out how to turn this into a useful module for everyone. So that's my talk. Questions? I have my glasses this time so I can actually see people. Sorry, at that end?
For what do you use it yourself?
I was using it for searching help because help search was so slow. I was using it to search our source code to find things without firing up Visual Studio and waiting 20 minutes. And also trying to do some log analysis. But I'm not an admin. I don't have, it's like the event log analysis stuff was a result of a conversation this morning. I was using the help stuff earlier. But anyway where you want to manage a simple table, I think NuGet, for example. NuGet searches are really limited, but if they did an index of all of the contents of NuGet through, we could find all of the like if there's a buggy commandlet, we can do a full text search against all of the contents of the PowerShell gallery. Oh look, they're using this buggy commandlet. It's the wrong version. We should make them fix it, right? And it takes fractions of seconds. I mean, we could really index and search all of what's in PowerShell gallery right now in milliseconds. So, like I said, the possibilities are mindless or endless as you choose. It's just a question of finding it out.
So are there document ingesters for the Word Office documents?
Probably.
And then, so when you do the search, do you have to get the content back, or can you get the metadata back and then?
There is no metadata. Right, it is the metadata is the content.
It's like if I indexed a PowerPoint document,
right.
Am I going to get raw text back, or can I get the name of the PowerPoint document and maybe the slide number?
If you, so that's where you have to have a custom analyzer. So if you want to pull out a specific piece of data to search against, rather than simply indexing all of the text in the PowerPoint document, you would have an analyzer that would pull out, say, the slide number and the title as separate fields. and then you could do it that way. Or you could index each of the slides as its own thing with the slide number and title, and then find it that way.
But you have to get the content back, or do you get the document name that?
It returns the content, but you can extract what you want. So it's a full text retrieval system. I wouldn't recommend indexing the full works of Shakespeare as a single document. That seems unwise because you'll get it all back. But you might want to like in individual acts or whatever, maybe. So you have to consider the type of data you're indexing and how much of it you want to get back. But yeah, you can still get specific fields back. If you query against a field, you get that field back. I believe. I'll check on that. Somebody else had a question? We'll way in the back.
If this is really so fast, why isn't it already implemented in, for example, Cortana and GitHub already?
Cortana uses a full text search, but a different kind of search, right? So Cortana is using deep learning and convolved neural networks to do pattern analysis along with semantic graphs to track association. So it's a different type of thing, right? What Cortana does is a much more sophisticated type of search. It's not just full text search. Bing is, even things like Bing, right? They do use, so they use full text search, but they also use augmented transition networks and convolved neural networks for pattern analysis and a whole lot of more sophisticated technologies that you don't want to build into your PowerShell script. But Cortana does use things like an augmented transition network. It uses both old AI and new AI.
Where do my files have to be I want to index? So can I use some kind of SMB share for my customers, SMB shares that I can index their
That's all
files?
I'm doing is I'm dumping all these files out into the file system and then just saying, grab every file and just ingest it. Right, that's all it does is it iterates through the file system, so it reads the file, ingests it, and this indexing involves opening and reading every single file, not just simple indexing. So it's because the API is you add a document to the index. So that 3 seconds to index 10,000 records was opening 10,000 files, reading 10,000 files, and then ingesting 10,000 files. I haven't separated out how long it takes to do just the open and read versus the ingestion, but it's pretty fast.
And is the index single user?
Yeah, it's a single process, right? And so if you do it in memory, then, well, obviously it's a single process, but it is a single process. So architectures like Elastic Cloud and so on build these worker nodes, where each worker node has its own database, and then they use distributed transactions across the set of nodes, right? So as I said earlier in the slide, high availability is done at the higher layer, right? This is designed to be a super simple thing into which you can add really quick indexing. If you have a little website and you want to index it really, really fast, you can just put this into your web application. It's so lightweight, it's not like, if you lose your index, just re-index, it's like no big deal, right? So it gives you a flexibility that you don't have with like a SQL store or whatever, or even Jet. Like Jet doesn't really let you search, right? It would be really interesting if, for example, Outlook, which uses Jet as its underlying store and is really slow to search, used something like Lucene. And then we'd be able to do like full searches of the mail in like milliseconds. That would be awesome. Yes?
You said you can use markers like title or body to search for special text. Do you have to, can you define these markers?
Right, so that's what the analyzers do. So the analyzer is the thing that takes a piece of text and formats it in a way that it gets passed into the database. Every item has to have at least one field. So what I'm doing here is there's one field when I'm indexing. There's a single field called text, and everything is stored into that field. But because that's what the default analyzer does. But you can write a custom analyzer. My plan is to write a custom analyzer that takes a PowerShell class and uses that as the metadata. And then you can just index classes. So you have a whole bunch of classes, you just pass them to Lucene, and now you can retrieve that data. And so you have remember we talked about having a structured external object store where you'd have, like just put stuff in it would be persisted? Yeah, that we could do with that. So, and again, it gives you almost real-time retrieval. It's almost as fast as just getting an object out of a hash table. Maybe not, but it's blindingly fast. So you might, as you might have gathered, I'm really excited about this technology. I don't have a really super good concrete use for it right now, and I haven't had a chance to like fully evolve my understanding of how to apply it. But it's just so exciting that you have this incredible search capability, because search is the root of so much stuff that we do. Anyone?
You could build it in for the help system.
We certainly could. I would love to do that. And now that we're much more friendly towards open source, because it's an open source project, now that we're more friendly to open source and are able to do things like pull Pester back into our product, it might be feasible for us to do that. Yes?
Is the index only memory?
No, you have a choice. You can index in memory, or you can index onto the disk. I'm indexing onto the disk, so I'm actually using the slowest path. But if you want to build a memory, index in memory, like for a lot of, for example, if you're doing like Elasticsearch of text, for example, but you have, by the way, I'm wearing an Elasticsearch t-shirt, this is the logo, thought it would be cool, is that if you want to have super high-speed retrieval, more and more you're finding that people are doing in-memory databases just to improve performance. The most recent release of SQL has much more in-memory operations, just because it's fast, and if the data is like at the beginning, the reason I said everything you know is wrong is in the admin world, you don't have anything like a bank statement that is absolutely guaranteed to be right. There's no acid in transactions, and like you can't unlaunch a rocket, you can't undelete a disk, and so when you have information, you get information through your event logs. That's all stale, right? Stale by a lot, stale by a little. And so you have kind of nebulous data to begin with. And so if this thing blows up, well, you can just re-index and grab the data. And if you're a little bit wrong in the database, well, you were anyway, so.
I was thinking about many folders containing syslogs of VMware servers. And I don't want to index every time I want to make a search.
Right.
So.
Yeah, and so that's the thing. This does allow for incremental index. I'm just building an index completely every time, but you can build an index, and in fact what I'm doing is I create the index, I add a file to it, add a file to it, add a file to it, and add a file to it. So you could do exactly that, right? You have the process running, and the index is saved to disk, so you can restart and reuse your index. And I'm hoping that if they get nuked, they leave the index in a stable state. You may lose information, but it should be, hopefully it's journaled. I need to check on that. But yeah, you can do exactly that. Every time you get a new, like the log rotation server creates a new rotated log, you can index that and add it to the index. And so you're not re-indexing 12 billion logs. You're just doing one at a time. In fact, once you've indexed it, you can blow it away because you have the full text in the index with minimal overhead. Anything else? So I expect everybody to run out and play with Lucene right away.
Where do we get it?
Lucene.net. Just look for that. I think we were going to put all these samples up for Tobias. Is Tobias here? No. I assume we're going to make all of the code samples and stuff available to people. She says, sure, whatever.
Yes.
Okay. Yeah. So.
Yes.
Yeah. So yeah, I'll give those samples so that people can play with them. They're just like a start to play with. I hope all you very bright people can think more appropriate applications for it. But I had so many discussions about with people about Log Analyzer. That just this thing is just so awesome. Right? I mean, you could do such a good job of log analysis, and in fact, we do. It's called operational insights. So there you go. If there's no more questions, I'll wrap it up. And thank you.
I don't know.